Hi everyone, welcome to the second lesson here, or I should say in our notes for 3.0, it's the second set of notes, and it's called Pythagorean Theorem. So in our chapter 3 note booklet, we've finished looking at angles in a triangle, and now we're looking at Pythagorean theorem. And this is a really important theorem in geometry. It allows us to find the missing side length of a right triangle where we're given two side lengths. So in other words, if we have a right triangle that looks like this, okay, and I have that little box there to say that this is in fact a 90-degree angle, which is a right angle. And if I'm given two sides and I need to find the third leftover missing side, I can use Pythagorean theorem. So for some triangle where A, B, and C, okay, look like this on our triangle, we're going to be able to use this formula. I want to mention to you, first of all, that this formula needs to be used in a certain way. And by that, what I mean is that this value for C here, C is a really specific side of the right triangle. This is the hypotenuse. So C is the hypotenuse. And we have to ensure that the value that we're putting in for C is the value of the hypotenuse. If we don't, and we mix it up, and maybe we think that the hypotenuse is A, we're going to get the incorrect answer. We need to use this formula correctly. So it's really important that when you're looking at any right triangle, the side that's directly opposite your right angle, that side is always your hypotenuse. And you should label that right away on a right triangle. So know right away where your hypotenuse is. It is this side length. Okay, in this case here it's C. Okay, and you need to always label that so that you know this is C. Now, A, okay, and B, there does not matter whether you labeled this side over here could be A or B. This other side could be A or B. It really doesn't matter there. All that matters when you use Pythagorean theorem is that you correctly label the hypotenuse and you ensure that that's your C value when you use the formula. Okay, so let's go ahead and use this formula to solve for a missing side length. First of all, you'll have to be given two side lengths to figure out what the third one is. Okay, you need to have two of the three pieces of information. The other thing we need to recognize here is that in the formula, the side length A has been squared, B has been squared, and therefore what we're getting for C as our answer is a square, and we have to undo that squaring by square rooting C. Okay, so what we're going to end up with is C is equal to the square root of A squared plus B squared. Okay, and we'll deal with that in a moment. Let's go ahead and try a real example here. So example 1, find the unknown side length. I see that I have 2 of 3 sides, so I can use Pythagorean theorem. Go ahead and put a little right angle symbol in the corner of this triangle. It should be there in our notes. So that tells me that this is a 90-degree angle, which means that I definitely have a right triangle and I can use Pythagorean theorem. Okay, so the theorem is this. It's A squared plus B squared is equal to C squared. And I certainly have to figure out where my hypotenuse is on this. So let's go ahead and label this triangle A, B, and C. But before I label A and B, I want to make sure I know where my hypotenuse is. I look for my right angle, which is this square, and I look across opposite from that right angle. This side length right here is my hypotenuse. So I'm going to go ahead and call that C because that's the correct that's what I need to use in my formula. That's going to be C, the hypotenuse right there. So in this case, I'm actually looking for the hypotenuse. I can label then the other side, the 5-meter side, to be A, or I could have called it B. This really doesn't matter. We'll still get the same answer. But I'll go ahead and call 5 meters A, and let's call the other side of 3 meters B. So what I'm going to do here is I'm going to plug in what I know into my formula. So A is 5 meters, so I'm going to put in an 5 for that A. Okay, and I have to square that because the formula tells me to. And B is 3 meters, and I'm going to square that. And that's going to give me C squared. Okay, 5 times 5 is 25, so I get 25 meters squared plus 3 times 3, which is 9 meters squared, equals C squared. We can add 25 and 9 together, and that's going to give us 34 meters squared. And that's equal to C squared. At this point, I'm almost done. The only thing I have left to do here is square root C squared and square root the other side of this equation, 34, because I want to know what is the value of C. I don't want to know what the value of C squared is. So to undo squaring, I square root it. So I'm going to take the square root of the number 34, and that's going to come out to be 5.83. And meters squared, when I square root meters squared, I get meters, which is exactly what I have up in the same units as my other sides in meters. Okay, so this question here, we were looking for the hypotenuse. So we were looking for C. And so we can plug in A and B, square them, add them together, and then square root them to get our value of C. Let's try another one. Okay, you have another example here. Again, what is the unknown side length of this triangle? Please put the 90-degree angle in at the bottom right corner here. Okay, so we have a right triangle, and again, first thing I'm going to do is figure out where my hypotenuse is. Find my right angle and look right across from it. There is my hypotenuse. Okay, so my hypotenuse is the side that I'm looking for. And it's the side across from the right angle. So again, I'm looking for C. Now that I've figured out where the hypotenuse is, I can label the other two sides A or B, and it really doesn't matter what order. So I could call this one A and this one B, and that's fine. Okay, so let's use our Pythagorean theorem. A squared plus B squared equals C squared. Plug in the values that you have. So let's put in a 3 for A. Okay, plus a 4 for B. And that's going to be equal to the hypotenuse squared. Well, 3 times 3 is 9. Okay, I'm just going to drop my units for a moment just to kind of simplify my calculation. And 4 times 4 is 16, and that's equal to C squared. Well, 9 plus 16 is 25, and 25 is equal to C squared. So the last thing I need to do here is square root this C squared to get C, and I have to square root the other side of that equation to keep it equal. And so I get C is equal to the square root of 25, which is 5. And if I come back and look at my units here, I'm in meters. So I solved for my unknown side length. It's equal to 5 meters. So from there to there is 5 meters on my right triangle. Great. What happens if the side that we're looking for isn't the hypotenuse? This is really important. Have a look at your last example. And when you're looking for an unknown side length, again, it's so important to label the hypotenuse, because if you're not looking for the hypotenuse and you're looking for A or B, you do have to rearrange the formula, Pythagorean theorem, this formula right here. Okay, so let's look at this triangle. Again, there's my 90-degree angle. Let's put that in for ourselves. Immediately, I start by labeling my triangle. So let's look across from that right angle. So the 6-meter side over here is C. It's my hypotenuse. Okay, so right away I can see I'm not looking for C. Okay, I'm going to call this side over here A and this side over here B. Okay, which means, based on how I've labeled my triangle, I'm looking for one of the other side lengths, which is A in this case. Okay, anytime you're looking for A or B, you are going to have to rearrange this formula here by subtracting one of the values over to the other side. So let's start off by plugging in what we know. So I'm going to substitute in the values of C and B into my formula, and I'm just going to leave A squared like this, A squared, okay, because I don't know what the value of A squared is yet. But I know B is 3, so I'm going to put in 3 squared for B squared, and that's equal to C squared, which I know is 6, so I'm going to write 6 squared for C squared. Let's work out the math. We have a squared. Okay, well 3 times 3 is 9. And 6 times 6 is 36. So I have a squared plus 9 is equal to 36. What's important here is that I'm looking for a squared. I need to get a squared all by itself on one side of the equal sign so that I can square root the numbers on the other side. So because I have this 9 here, I need to move it over to the other side. Okay, I have to get it. I need to undo what's being done to a squared, and it's being 9 is being added to a squared right now. So to move this over to the other side, I'm simply going to subtract 9 from this side, and I'm going to subtract 9 from the other side to keep it equal. And I've moved that 9 over. So now what I have is a squared is equal to 36 minus 9. Well, 36 minus 9 is 25. And I'm going to now, oh, I'm sorry. I made a quick math error. 27. My apologies. 36 minus 9 is 27. So now I've got a squared equals 27. I just need to figure out what is a. So now I'm going to square root both sides, just like I always do. And that will give me a equals the square root of 27, which is 5.196. And so we could even round that up to 5.2 meters. Those are my units. Okay, so just be careful when you're given a triangle, make sure you immediately label the hypotenuse. Then label your other two sides, A or B. Okay, that ensures that when you're using this formula, you're using it correctly. Okay, don't assume that the side you're always looking for is always going to be C, because that's not always the case. So first label your triangle and then plug in the values that you're given, solve for the one that you need. I'm going to get you to try your worksheet in your Chapter 3 worksheet package. It's the first one. It's called Triangles, and the answers are there for you to check, but give them a try. There's a few different right triangles. Sometimes you are looking for the hypotenuse, sometimes you're not. So give those a try and check your answers. Thanks for joining me. Bye for now.